Hey guys, Mr. Riz here. I'm going to help you out with the last part of the 1.4 notes. Now what we're going to be doing is looking at piecewise functions, but we're going to try to evaluate missing numbers here to determine a continuous function. So if I have this equation here that we start out with, the piecewise function is 3x squared for any x less than 1. And then we have an equation that's ax minus 4 for any x bigger than 1. I want to know what value of a we could plug in to figure out to make this a continuous function. And really to help us out, what I'm going to do is I'm going to use Desmos here. So on Desmos, I have the piecewise function set up for any x less than 1. We're going to use 3x. And then I'm going to make another piecewise function here for any x greater than 1. Let's see, I'm going to have ax minus 4. Now the cool thing about Desmos is if you click add a slider, we can actually take the slider and move it up and down. So our goal here is to figure out what number to plug in for a that will make this match up perfectly. We can probably get really darn close here and probably say, I think 7 works. Now, let's explain 7 mathematically why this works out. All right, because remember, if I take 1 and plug it into this equation, I'm going to get the point 1 comma, if I plug that in, that's 1 squared times 3, 3. What we want to do here to make this a continuous function is make sure when we plug 1 into this equation, we also get 3. So what that means, remember the way an equation works is if I plug 1 in for x, so a times 1 minus 4, that equation needs to equal the point value 3. All right, so that means that we get a minus 4 equals 3, and I can add 4 over to 3, and I'd get a equals 7. So Desmos does a really cool thing with our sliders to help us out that we can evaluate that, but mathematically that's what we're trying to do. So let's do the next one here, but this one has a's and b's. All right, so I'm going to set this up just piecewise function. Meant to delete everything, but I doubled that in. All right, so let's do for any x less than -1, we're going to have the equation 2. And this one here, we're going to have for -1, which is less than x, which is less than 3, we're going to have ax plus b, which we need to add a slider for. Okay, we have a slider for a and for b. Can I move those around? Yeah, there we go. And then I need to add another one for any x greater than 3. We're going to have a 3 minus x. Okay, so if we notice here, we have I need to kind of flip this up and down. B moves it up and down. A kind of flips direction. So I need to kind of make the points line up here perfectly. So maybe I can snap it in there, and then that doesn't work out quite nice, but maybe slide up a little bit more. All right, so we're getting kind of close. What we do here, what we can kind of think of, this is technically the equation for a line, right? This is y equals mx plus b. So if I look at this point here, I know if I plug 1 in for, I'm going to try to get to the point -1, 2, which is actually right here, -1, 2. I'm going to try to get it to match up. I plug in 3 for here, match up with the point 3, comma, I plug in 3, 0. All right, so I just want to find the equation of the line that hits those points. So y equals mx plus b will help me figure this out. Let's find our slope by subtracting the y's. All right, so subtracting the y's, we got 2 minus 0 over -1 minus 3. So that means I would have a 2 over -4, so that means my m would be -1/2. And so that's what a should equal. And you know what? I had -0.6 here. I could probably change that to -0.5, and I'd get really close. All right, now to figure out the b, I can take either one of these points here, and I could plug in our m and our x and y to figure that out. So with y equals mx plus b, our y is 0, our m we figured out is -1/2, x was 3. We're going to figure out what b is. So we get b equals, this would be -3/2 plus b, so b would have to equal +3/2. And that's what, 1.5 as a decimal? Can I type in Desmos 3 divided by 2? Look at that. Now they match up perfectly. All right, so Desmos is actually going to be a really good, helpful tool to help you guys figure these out here using the sliders. So if you guys have never messed with sliders, this is a good way to do it. Sometimes with sliders, you can do things like I press this play button where it goes back and forth through the range, and we can kind of figure out what would be close. We can pause it. We have no idea. You can actually have multiple sliders move at the same time, but that's a good way to do this. All right, guys. So this wraps up 1.4. We'll start 1.5 tomorrow. You guys have a great day. I will see you then.